Hello. Hello and welcome to this video. In this video, we will solve problem number 101 to 110. So get ready with pen and paper, and when I'm stating the problem, you should pause the video, try to solve the problem yourself. If you cannot solve the problem within 15 minutes, then leave the question and move on or look at the solution. If you choose to move on, come back later and try to solve it. If you can't solve it in certain attempts, you can look at the solution. The link to download the PDF will be in description, and at the end I will show you how to download the PDF from the website and the trigonometry book as well. So without further ado, let's get started. Question 101 says that M men and N women are to be seated in a row so that no two women sit together. If M greater than N, then show that the number of ways in which they can be seated is M factorial multiplied by M plus 1 factorial over M minus N plus 1 factorial. So M men can be seated in M factorial ways, which will leave M plus 1 positions between them and on the edges. So how do we get M plus 1 is, suppose we have two men, then in between there will be one position, and on the sides edges there will be two positions, so 2 plus 1 3. So if you have three men, then in between them there will be two positions and on the edges 2. So similarly, if you go on, M men are seating, then there will be M minus 1 gaps between them and 2 on the edges, so M plus 1. Now we can seat N women out of these M plus 1 positions in M plus 1 Pn. So total number of ways of seating women will be M plus 1 factorial by M minus N plus 1 factorial. And number of ways to seat men is M factorial. So total will be M factorial multiplied by N plus 1 factorial by M minus N plus 1 factorial. Question 102 says that 3 women and 5 men are to sit in a row. Find in how many ways they can be arranged so that no two women sit next to each other. So exact duplicate of the previous problem, substitute m is equal to 5, n is equal to 3, and you will get the answer as 5 factorial multiplied by 6 factorial over 3 factorial. Question 103 says that find the number of ways of arranging 5 A's, 3 B's, 3 C's, 1 D, 2 E's, and 1 F in a row if letters C's are separated from one another. So we have 12 alphabets excluding C's, out of which 5 are A's, 3 are B's, 1 D, 2 E's, and 1 F. So these can be arranged in 12 factorial by 5 factorial into 3 multiplied by 3 factorial multiplied by 2 factorial. So now we will have 12 alphabets and we will have 13 positions between them and on the edges, and which can be filled by 3 C's in 13p3 ways. So total number of arrangement is 12 factorial over 5 factorial multiplied by 3 factorial multiplied by 2 factorial, and this would be multiplied by 13 factorial by 10 factorial. Question 104 says that find the number of different permutations for the letters of the word banana. So A repeats 3 times, N repeats twice. So total number of alphabets is 6. Therefore, number of permutations is 6 factorial by 3 factorial multiplied by 2 factorial. Question 105 says that how many words can be formed from the letters of the word circumference taken all together? So there are 13 alphabets in the word circumference. C comes thrice, R comes twice, E comes thrice, and rest come once. The total number of words that can be made is 13 factorial over 3 factorial multiplied by 3 factorial multiplied by 2 factorial. Question 106 says that there are 3 copies of each of 4 different books. In how many ways they can be arranged in a shelf? So there are 12 books with repetition of copies. The total number of arrangements on the shelf is 12 factorial by 3 factorial multiplied by 3 factorial multiplied by 3 factorial multiplied by 3 factorial. Question 107 says that, so these are all formula based questions. Find the number of permutations of the letters of the word independence. The following like circumference, we have n 3 times, d twice, e comes 4 times, and rest come once. So total number of words that can be made is 12 factorial over 4 factorial multiplied by 3 factorial multiplied by 2 factorial. Question 108 says that how many different words can be formed with the letters of the word can be formed has come twice. With letters of the word principal so that vowels are together. So there are 8 alphabets in the principal, out of which P comes twice, I comes twice, and rest occur once. Treating all vowels as one alphabet, we have 6 alphabets which can be arranged in 6 factorial by 2 factorial. However, the vowels themselves can be arranged among themselves in 3 factorial by 2 factorial ways. Thus, total number of words is 6 factorial multiplied by 3 factorial over 2 factorial multiplied by 2 factorial. Question 109 says that in how many words can be formed with the letters of the word mathematics? In how many of them the vowels are together and consonants are together? This X is extra. So there are 11 alphabets in the word mathematics. M comes twice, A comes twice, T comes twice, and rest come once. So total number of words that can be formed is 11 factorial by 2 factorial multiplied by 2 factorial multiplied by 2 factorial. Now treating all vowels as one alphabet and all consonants as one as another, we have 2 alphabets which can be arranged in 2 factorial ways. But 4 vowels can be arranged in 4 factorial by 2 factorial ways, and 7 consonants can be arranged in 7 factorial by 2 factorial multiplied by 2 factorial ways. So total number of required words is 2 factorial multiplied by 7 factorial multiplied by 4 factorial over 2 factorial multiplied by 2 factorial multiplied by 2 factorial. Last question, question number 110 says that in how many ways can the letters of the word directed be arranged so that the 3 vowels I, E, and O are together? So there are 8 alphabets in the word director, out of which R comes twice and rest come once. Since the vowels have to come together, we treat them as one alphabet, making a total of 6 alphabets, which can be arranged in 6 factorial by 2 factorial ways because R comes twice. However, 3 vowels can be arranged in 3 factorial ways among themselves, making number of such words is 6 factorial multiplied by 3 factorial over 2 factorial. So with this, we come to the end of 110 questions, and these are still relatively very easy questions. And as we will progress, the question will get harder and harder. So let's see how many questions are there. 526. So that is quite a lot of questions. And you will see that questions really get hard later on. Okay. So make sure your basics are fine, because if you don't have your basics proper in place, then you won't be able to solve the hard problems. That is why it is important to pay attention in the easy solutions so that you develop muscle memory. Now to download the PDF, you can come to my website testavocker.org. You don't need to type www. You hit testavocker.org and it will come. It will redirect automatically. So second link is the algebra PDF, and third is trigonometry. You can download both and study at your own pace. You don't need to wait for video. If you want to go fast, you are most welcome. And ideally, you should go fast actually. You should not wait for my videos. And if you get confused in any problem, leave me a comment and I'll try to help you with the solution. Also, if you find a typing issue, there are lots of typing problems. Please report them and I'll be grateful for your report. Make use of comment box to report the typing mistakes. So I hope that you are enjoying this playlist on Algebra and finding it useful for your studies and exams. And I'll see you tomorrow with another video of 10 more problems. That is problem number 111 to 120. And we will study together. So thanks a lot for watching the video. I'll see you in the next one. Till then, stay curious.